everyone, thank you so much for coming to this lesson. So today we're going to be going through binomial expansion. So what would be really useful is if you review the lesson we did when we were just multiplying out brackets, as we'd use that a lot here. So the learning objective is to be able to understand and use the binomial expansion of ax plus b to the power of n and know when this the values that this is valid for. So like always, there'll be timestamps in the description of the video, so feel free to skip to any parts you want to. So let's get started. The first thing you need to know is what actually is binomial expansion. So that's just when you're multiplying out brackets. So for example, if we had 1 plus x to the power of 0 and we wanted to multiply it out, well, that will just be equal to 1, as anything to the raised power is just 1. And then if we continue this, so if we had 1 plus x to the power of 1, that would just be equal to 1 plus x. Then if we had 1 plus x to the power of squared, using normal multiplying out brackets, that will be equal to 1 plus 2x plus x squared. And then if we moved on to a higher power, we had 1 plus x to the power of 3. That would be equal to, if we do that multiplication out separately, so we'd have 1 plus x and then 1 times 1 plus x squared. So if you add the two powers of the brackets, that would get 3. So then that would be equal to 1 plus x times 1 plus 2x plus x squared. So then if we multiply that out, you'd get 1 plus 2x plus x squared, and then plus x plus 2x squared plus x to the power of 3. So then that's just, if we collect like terms, we would get here, we would get 1, and then we get 2x plus x, so that's just plus, so let's start plus 3x, and then we would have x squared plus 2x, that's also plus 3x squared, we would have plus x to the power of 3. Now, what's really clever about binomial expansion is that if you continue doing this expansion for higher and higher powers, the pattern you'd have for the coefficients in front of like x and x squared and x cubed, and as you go on, that's in the form of what is also known as Pascal's triangle. So that is, if we start from the top from here and we drew out the triangles, you'd have 1, and then you would have 1 and 1, and then you'd have 1, 2, 1. So we're just using the coefficient in front of each term of the expansion. And for the last one, we'd have 1, 3, 3, and 1. And what Pascal's triangle is, it's saying that every number in the last row is just the sum of the two numbers on top of it. So let's say we do this one. So we have 1 here, that's just sum of 0 and 1, there's no term here, so that's just 1. Then 3 is the sum of 1 plus 2, so that's 3. And then this 3 is the sum of 2 plus 1, and then this 1 is the sum of 1 plus 0. And then if you check this for yourself, the other values here, you'd get the same result. So that's what's really special about binomial expansion. So the pattern of Pascal's triangle will continue as you increase the value of power for the binomial expansion. So there's a formula that you can use instead of writing this all out, as that will get quite complicated. So I've written out the formula here for the binomial expansion of 1 plus x to the power of n. And let's just see how you could use it. So let's say, for example, you wanted to find out the coefficient of x squared when n is equal to 5. So if you would just sub in 5 into this expression, you would get 5 times 4 all over 2. And that's just the same as 5 factorial over 2 factorial times 3 factorial. So if you think about it, if we were just to expand this, and you'd get 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. So then if we were just to cancel these three expressions, you'd just be left with 5 times 4 over 2. We had this expression, when you plugged in the numbers, that's just the same as 5 factorial over 2 times 2 factorial. And so you can generalize this further by saying this would just be equal to 5c. This is because whenever we have something that's in the form of NCR, that's just the same as n factorial over r factorial times n minus r factorial. So if we were to sub in the values of 5 as n and r as 2, we'd get 5 factorial over 2 factorial times 5 minus 3 factorial 2 factorial, and that's just equals to 3. So you can basically just simplify this whole expression further by saying that this value is the same as NC1, this value is the same as NC2, and then this value is the same as NC3, because when we were trying to find the value, the x coefficient for when n equals 5, we just got 5c2. So we can generalize the whole formula for binomial expansion further by using what we just learned. So if you have a plus b to the power of n, that's just equal to a to the power of n plus nc1 a to the power of n minus 1b plus nc2 a n to the power of 2b squared, and so on. And you would have last expression is ncr times a to the n minus 1 b to the power of n r, and that goes on and on until we get your last expression, which is just b to the power of n. So for example, if we do like a small one, let's say we wanted to find out the expansion of 1 plus x to the power of 3, our a would be 1 and our b would be x and our n is 3. So we plug that all in. So your first one is 1 to the power of 3, and then we would have nc1, which is just 3c1, and then you would have a, which is 1 to the power of 3 minus 1, which is 2, times b, so that's just x, plus nc2, so 3c2, 1 to the power of 3 minus 2, which is just 1, times x to the power of squared, and then your last one would be plus 3c1, so you just keep going, nc3, so you just keep increasing, a to the power of n minus 1, so 3 minus 1, 3 minus 3, which is just 0, times x to the power of 3. And that's just equal to 1 plus 3c1, which is just 3, so 3x, plus 3c2 x to the power of 2, that's just 3x squared, so you can also use your calculator for this, plus 3c3, which is just 1 to the power of 0 is just 1, and then plus x cubed. So that's also your b to the power of n. So let's try an example of binomial expansion. So the last kind of binomial expansion that you need to know is when you have 1 plus x to the power of n, and n can be any real number. So this is extremely useful when you have n as like a negative number or like a fraction, and instead of using NCR because for like these coefficients, because that only works when you have a positive whole number. What you can do is you just have this formula, and what you do is you just plug in whatever value of n you have into this formula. But bear in mind that for this formula to work, you have to always make it into the form 1 plus x. So x, the mod of x, always has to be less than 1. So this means that that means that x can't be, that means like this value of x, that can't be greater than 1 or less than -1. So if, let's say, you had a value of like 2x, you can't have that. You basically, this means the value of x has to be in between -1 and 1. So if you've forgotten how modulus works, make sure you review that lesson again. So 1, it would only work if it's 1. So if we try an example next of how you can actually apply this formula to an example. So we have an example here, and we want to find the binomial expansion of the square root of 4 minus 3x up to x cubed. So remember what I said, we need to have it. So remember, you can pause the video here and then try it out for yourself. So remember what I said, we need to have this bit in the form of 1 plus x to the power of n, and n can be any real number. So the first thing we want to do is we want to rewrite this in as a power to have, so we can get n. So if you remember, anything square root is just the same as that to the power of half. So this is the same as 4 minus 3x to the power of a half. And now the next thing you need to do is we need to try and make this 1, and we want to try and make this just a value between -1 and 1. So we can just take out 4 from the brackets, and then we'd have 1 minus 3 over 4x. And that is all to the power of a half. So a common mistake here is that some students won't leave 4 into the brackets, and so they would forget to do 4 to the power of a half, but that's not right. So you just need to remember that when you are simplifying and taking out a multiple to get 1, you keep that in the bracket so you know to raise that to the power that you have outside. And now we can just plug in our values into this equation. So that would be to 4 to the power of half, then in bigger brackets we would have 1, and then we'd have minus a half times 3/4 x, because we have so we could just do plus minus half, and then that's probably an easier way to see it. Then we do plus a half, and then half minus 1 over 2, and then that's minus 3 over x squared, and then plus a half minus 1, and then half minus 2. So as you make your expansion like larger, whatever you have in the brackets, you just do that twice, but subtracting another one. So we had -1 here, so we have that, we have a -2, and if we continue, we would have half minus 1, half minus 2, and then half minus 3. So it just continues like that. And we have that 1 times 2 times 3. So this should have been 1 times 2. So that just increases, and then times minus 3 over 4x to the power of 3. And then if we solve that, you'd get 4 to the half, that's just 2. Then you would get 1 plus 3 over 8x plus x squared plus 27 over 1024 x to the power of 3. So remember, this is just plugging it into your calculator. And then finally, if you just multiply that out, you'd get 2 plus 3/4 x minus 9 over 64 x squared plus 27 over 512 x cubed. Yeah, so again, many students would just forget to multiply the 2 of that whole bracket. So to avoid doing that, just make sure you keep your 4 to the power of half on the outside of your bracket. And that's how you solve this. So it's quite simple. It's just using the formula, but making sure it is in the form 1 plus x to the power of n. So you always just have to have a 1 on the outs for this one, and that's only when n is if you have like a negative number or like a fraction. But if this was just like 2 or power of 2 or power of 3, you can do what we were doing before with a plus b to the power of n, and then just subbing in like the NC1, the NC2, etc. So the last bit we want to do is we want to work out when the binomial expansion, what values of x it would be valid for. So in general, if you have a positive, if n is positive, then the binomial expansion of p plus q x to the power of n is just valid for all values of x. So this is like if it was like 2 plus 4x to the power squared. So if whenever n is positive integer, the values of x, it'll be valid for all values of x. Then if n is a negative integer or a fraction, then you would have your binomial expansion of p plus q x to the power of n would only be valid for when the mod of q x over p is less than 1, or, which is probably easier to work out, the mod of x is less than p over q. So these are just the same. So if we try that out, we have these two examples. So feel free to pause the video and try it out for yourself. So for the first one, we have 1 plus 2x to the power of 3, and we want to find out where it's valid for. So this is a fraction, so it would be using this, and that would just be valid for when the mod of x is less than p over q, so that's just 1 over 2. And then for this one, you have a fraction. So if you have a fraction with 2 separate binomial expansions, you do it separately. You work out where it's valid separately, and then you work out the values that are common to both. So for the first, for 1 plus 2x to the power of 3, because 3 is positive integer, that's just valid for all values of x. And then for the last one, remember that because this is a fraction, this is just the same as 1 minus x to the power of minus 2. Yep, so because 2 is a negative, minus 2 is negative, so we use this. So we say the mod of x has to be less than p over q, and here the x value is minus x, so remember that. So it would just be minus x. The mod of minus x has to be less than 1, it's just p, and q is just 1. So the mod of x the mod of minus x has to be less than 1, which is the same as saying the mod of x has to be less than 1. Because mod of a negative number is just a modulus could not be negative, it would always be positive. So let's try an exam question here. So feel free to pause the video and try it out for yourself. So we want to find the binomial expansion of the square root of 1 plus x over 1 minus x, and we want to show that it's equal to that. So the first thing we want to do is just write out using like a power. So we'd have the square root of 1 plus x over 1 minus x. That's just equal to 1 plus x to the power of half over 1 minus x to the power of half. So remember, the square root is always something to the half, and then we can split it up. And then to get all in like one line, we would have 1 plus x to the power of half. And then this, if it's a fraction and it's to the power of half, that's just minus half. So we get 1 minus x to the power of minus a half. Now we can just do each of these expansions. So using the formula here, we can do the binomial expansions for both terms. So we'd have 1 plus x to the power of half, that's equal to 1 plus a half x plus half times half minus 1 over 2 factorial times x squared. We only need up to x squared because that's the last term we have. And then that's just equal to 1 plus a half x, and then half times minus a half, that's minus a quarter over 2 factorial, so that's just minus x squared over 8. And if we do the next one, we have 1 minus x to the power of minus a half, That's equal to 1 minus a half times minus x, because you remember it's this x term is, we have minus x there, so it's minus x, and then plus minus a half times minus a half minus 1 over 2 factorial times minus x squared, and that's just equal to 1 plus x over 2 plus 3x squared over 8. And now if we were to multiply these two expressions together, we would have 1 plus a half x minus x squared over 8 times 1 plus x over 2 plus 3x squared over 8, and that would be equal to 1 plus x over 2 plus 3x squared over 8, and then plus a half x, then plus x squared over 4. We don't need to go any further than that because we don't want an x cubed, and then we would have minus x squared over 8. And then if we were to simplify this further, we should get our answer here. So we get 1 plus x over 2 plus x over 2 is just plus x, and we would have 3x squared plus x squared over 4 minus x squared over 8. That should just be equal to half x squared, and there you have your answer. So if you ever have like a fraction like this, then just split it up and remember your rule of indices, and then you just have two terms that you can binomially expand individually, and then you can just multiply your expression together to get your answer. So thank you everyone, hopefully you found this video useful. So just to sum up, we learnt how to use binomial expansion and learn the when the expression would be valid. So make sure you do practice questions to fully consolidate your learning.